Now let us see the effect of ligand. So in complex already we know metal is acting as an acceptor and ligand is acting as a donor. So ligand also plays a major role in the stability of complex. So in this effect of ligand, we'll discuss the size and charge of the ligand along with basic nature of ligand. Okay, let us see the size and charge of the ligand. You can see I told you already ligand also should have a small size and high charge. Then only it can form a stable complex. So I'm giving you the example of halides. Halides are 7A group elements with valency 7. Okay, so you can see clearly if it is gaining one electron, it becomes more stable. So with 7 electrons, it is adding one more electron to form halide, and it is having 8 electronics configuration. Valence configuration will become 8. It will become a complete shelled configuration. So F minus is more stable than Cl minus. Cl minus is more stable than Br minus, and Br minus is more stable than I minus. So it is basing on size of the ligand. So from top to bottom size increases. So F minus will have a small size. Because of this small size, it involves in the stable complex formation. So small size with more charge, we can form more stable complex. Okay, next coming to basic nature. So what is meant by basic nature? According to Lewis theory, Lewis base and acid will come here. So Lewis base means which donates electrons to the other element. Okay, it should have a pair of electrons with it, so it is called as Lewis base. Lewis acid means it should accept electrons. So central metal ion is acting as acceptor, so it is becoming a Lewis acid, and ligand is becoming a Lewis base. So basic nature is there for any ligand because of donation of electrons. So the one which can donates electrons easily, that can form more stable complex easily. So ligand which donates a lone pair of electrons easily can form stable complex easily. So I can give you the strongest basis example, F minus and H3 are some examples. Because of stable electrons, it should donate electrons, then it become a more stable. So strongest basis donates electrons easily to form a stable complex. Next coming to effect of chelation. So already we have discussed chelation is nothing but formation of ring like structure. A chelated ligand will have a more than one donor atom with it. So cyclic ring formation. Whenever chelating ligand donates electrons, it forms a cyclic ring formation around a central element. So that cyclic ring formation is called chelate. So the stability increases with chelate ring formation. Whenever a complex is having a chelated ring, then it is more stable when compared to normal complex. I can give you the example. CuEn2 2 plus is more stable than CuNH3 4 2 plus. Here NH3 is a normal ligand and En2 is a bidentate ligand. So this bidentate ligand is forming a cyclic ring around the copper. So because of this, the stability around Cu in En2 complex is more when compared to normal Cu and H3 complex. So here stability constant you can observe 20.03, and here you can observe 12.67. So 20.03 is more when compared to 12.67. So because of this, more stability constant is there for En2 complex when compared to NH3 complex. This is about effect of chelation and effect of ligand. Next coming to the environmental factors. So environmental factors includes two types. One is temperature, other one is pressure. Even temperature affects the complex formation. That means temperature can make the complex stable or unstable. So if I observe this reaction, volatile, the temperature effects on a complex will be two main types. Okay, it may leads to the evaporation, otherwise it may leads to the transformation. It may leads to transformation means change in the complex. So evaporation means what? I am taking a complex, I am heating at high temperature. If I heat at high temperature, there is a lead of evaporation takes place. You can see here NH3 6 here, NH3 5 Cl. Okay, and one NH3 molecule is getting evaporated on heating at 175 to 180 degrees centigrade. Okay, next same another take if I take another complex, in this complex you can observe En ligand, ethylene diamine ligand. This ethylene diamine ligand at 210 degrees centigrade may get evaporated with ethylene diamine molecule outside. and Cl will enter into the coordination sphere in order to satisfy the valency. So now at 210 degrees centigrade, one ethylene diamine molecule is getting evaporated. So if I eat any complex, some complex at high temperature, there is evaporation of certain ligands. Okay, you can see here an H3 ethylene diamine can be evaporated. Next, it may lead to transformation. So some ligand may change their transformation. There is a change in the arrangement of ligands inside, arrangement of the entire complex. If I take this silver and mercury complex, if I heat at 45 degrees centigrade, it can change into yellow color. So beginning it is in red color, it is changing into yellow color. So entire color of the complex and inside arrangement also changing. This is called as a transformation. So effect of temperature will change the complex structure and color. Next, effect of pressure. Even pressure can affect the complex formation. You can see here, every chemical reaction there is a equilibrium process takes place on the reaction of ligand with any other molecule. So increase in pressure causes the backward reactions. If I start heating this complex, there is a formation of COCl2 and 6NH3. So if I increase the pressure, there is a chance for the combination of NH3 and COCl2 to take place the backward reaction. Okay, if I decrease the pressure, all molecules will become loosed and NH3 gets evaporated. So in such cases, backward reaction will not take place. So in order to make the reaction equilibrium, I should apply more pressure. Increase in pressure causes the backward reaction. So decrease in pressure allows the loss of ammonia molecules outside. Next, coming to concentration factors. So concentration is nothing but amount. So how much amount we are taking inside, the amount of ligands, amount of metal atoms also affects the stability now. High concentration in the presence of water leads to the stable gas configuration. So why we are adding water here? Water is acting as a solvent and which makes coordinating agent in the complex. Okay, you can see here CuCl4 2 minus, beginning it is yellow color solid. In the presence of water, substitution reaction is taking place. In place of Cl, all water molecules will be substituted. Then there is a formation of blue complex. Again, if same reaction I want to take it in the reverse manner, if same reaction is taking place in the backward condition, then I need to add more concentration of Cl minus ions. So I am adding 4 Cl minus ions to take place the backward reaction. So effect of, if there is a less amount of Cl minus, then the reaction will not take place and the backward product may not obtain. In order to get the backward product, I should add more concentration of Cl minus along with water. This reaction is taking place. So concentration also affects the stability of metal complexes. So this is completely about factors affecting stability.